question's asking on this? I can't remember. Is it going, does it converge or diverge? Sorry. So it's going to, it looks like it's going to. So the question is, you're doing the limit as n goes of sine n over n. Now, when you logic this out, what is sine n doing as n goes to infinity?
Oscillating.
It's oscillating, but is it bounded or unbounded?
Bounded.
It is bounded. Okay. So when you're looking at this, what's one way you are allowed to rewrite this limit? You could write it as the limit as n goes to infinity of what? Sine n over, sorry, let me jump down here, excuse me, over the limit as n goes to infinity of what? N. Well, we know if we're doing this in kind of hand-holding motion, this right here, what is this? Is that bounded or unbounded? We just said it out loud, so what is it?
Bounded.
Yeah, so that kind of the hand-waving way of logicking this out is you know that that top is, you know, you can think of it's going to be less than, it's going to be between -1 and 1. But what does the denominator go to? What happens to the denominator as n goes to infinity? N is going to go to, it gets really, really big. So this is the hand-waving way of logicking it out. So if you have something bounded over something going to infinity, look at that picture over there next to James's head. You see how it's going up and down right there? What happens here? This thing is going back and forth, but so it's going back and forth. So you have the sine curve, and then what happens as it goes, as n goes to infinity in the denominator? It just goes smaller and smaller and smaller and smaller and smaller and smaller and smaller. So it's going to get smaller and smaller and dance around above and below 0. It's going to dance above and below. Right now, that's all you need to know. That's fine. That's good. You can do a visual justification for me right now. That's fine. Totally fine. Yes. No, I understand what you're saying.
And then with the numerator also getting larger,
okay.
It's more exponentially larger.
Okay, you have to be really careful. You have to be really careful. So basically what you have is you have a numerator that's getting infinitely large. That's undeniable, right?
Yes.
The numerator is getting infinitely large. And the denominator, what's happening to the denominator, though? The denominator is getting infinitely large as well. So you have two things that are multiplied together. One of them is going to infinity, but what's happening to the other one? It's going to
Infinity.
Well, one of them is going to 0. You have something going to 0 multiplied by something going to infinity. The challenge is what happens basically, what happens when 0 and infinity go to war?
0, 1.
You sure? Is that always the case?
Most of the case.
Is that, well, hold on. You have to be really careful with the word most, because in math, there's generally 3 numbers of answers to things. There's one of them, 0 of them, or an infinite number of them, right? So there's a lot of different ways to set this up. So the question is it always the case that 0, when multiplied times something going to infinity, goes to 0, or does it go to infinity? Well, could it be either one? Does it have to be one or the other?
Well, if it's creating an indeterminate form.
Something that you had on your summer review, which indeterminate, what?
Infinity over
We will. We can talk about it. We will. So on this one, you use L'Hopital's rule, theoretically, in your last class.
Probably used it, but I don't think we called it that.
L'Hopital's rule, you didn't call it that?
We didn't.
Okay. The idea, though, is what is one of the indeterminate forms where you can use L'Hopital's rule? Does anybody remember that? Yeah.
0 over 0.
0 over 0 or?
Infinity.
And in this case, you do have infinity over infinity. So 2 to the n goes to infinity as n goes to infinity. N to the third goes to infinity. So what can you do once you notice you have an indeterminate form? Does anybody remember?
Differentiate.
You can differentiate the top and the bottom. Exactly. So if you differentiate the top, what's the derivative of 2 to the n? ln 2 times 2 to the n. And what's the derivative of n to the third? 3n squared. Oh, what do you have again? What can you apply again? You can apply the same thing because the top still goes to infinity and this bottom too. So you apply the symbol for this. Usually you see an equal sign with h. Means apply L'Hopital's rule. What do you get next? It turns into ln 2 squared 2 to the n all over what? 6n. Hey, can you apply L'Hopital's rule again? Yeah. So you end up applying it again, and you end up with ln 2 cubed 2 to the n all over 6. Can you apply L'Hopital's rule? No, because you can do the limit at this point. One of the easiest ways to mess with really advanced students is to give them something that seems to fit a mold, but you don't need to use it. You know, like I love giving kids limit tests where one of the questions you could just plug in the number and get it. It's continuous at the point, right? So at this point, you're cruising along. Should you do L'Hopital's rule? No, because what does this go to? So what happens? Do we know definitively this diverges? But this is a little bit, you need to, the notes are a little incomplete, but that's the basic idea. But this right here is pretty common. When you apply L'Hopital's rule, which you can apply as many times as you want, as long as you continually have an indeterminate form, it's usually h over the equal sign. What?
Where should we tell?
You can go into notes. You can go wherever you want to write things down, but keep in mind that you're going to get this in digital form immediately, so you don't need to write down anything that I put on the board. But if I say something out loud that I don't put down, feel free to write that down. You can put this anywhere you want in that notebook you've shared with me. Create a new page. You can always move the pages around, so it's not something you're totally stuck with. So we yesterday described an infinite sequence, which is an infinite set of numbers. What's the only change we're going to make to that infinite list when we go to series? What are we going to change? Any idea? It's right there on the board. What's the only difference between this, what we've written right there, and what we were looking at yesterday? There's an operation now. What's the operation? Sum. We're going to add those infinite number of things together. We're going to add those things together. The individual numbers are called terms. To talk about the sum of a series, we must to explain what it means to kind of go to infinity. If you add an infinite number of things together, what can happen? Let's say fourth instead. So after I take the first pill, 250 milligrams, right? I take the second one, but what's left? 0.04 of 250. So then I take the third pill, but what's left in my bloodstream? 0.04 of this amount. This amount went right there.
First point.
Sorry, excuse me. Haha, might need to actually add the 0.04 in every time. Like that. And then I took this, and what goes out here? 0.04. So you're adding 250 each time, but then what's going along for the right? 0.04 of what was there the last time. So what do you have? You have... I missed one on the inside too? Yeah. It's recursive, so there should be one, the 0.04 right here, right? I should not do that in highlighter. Right over there? Yeah. So the idea is this travels down to here, multiplied by 0.04. This travels down to here and gets multiplied by 0.04. So then could you do this out on your calculator and come up with a decimal?
Yeah.
Do that for me right now. Come up with the decimal. Tell me why I love 3 decimal places. 416.
Yeah.
Who said it? Was that Tori? Yeah, that's the AP number. If you don't go to 3 decimal places, you don't get the answer point. And do you want your points? Yes, you do. So let's look at something here. Let's look at it a little differently. Instead of trying to do it out step by step, it might be helpful for us to find a what? An equation. So let's look at that. Let's just start this again. Let's start it again and say, okay, we have 250, and then we have 250 plus 250 times what? 0.04. Can we simplify that a little bit? Factor out the what? 250 times 1 plus what? 0.04. Is that correct? Sure. What would the next line be? You'd have 250, right? Plus, hold on, plus 250 times 1.04 times what? What do we have to multiply by? 0.04. How can we simplify this? What could we pull out?
Take home
250.
250.
250? Yeah, we can pull out 250. So what does this become? It becomes 250 times 1 plus what? 1 plus what? 1.04 times what? 04. What are we doing so far? Are we doing okay? Yeah. What can we factor out now, though?
250.
Yeah, so let's keep track of parentheses here. We got 250 times 1 plus 1.04. Oh, wait. Don't close it. Times 0.04. Close bracket. This is where you have to be very, very careful about this. 0.04. Like that. I think that's the case. Right? Did I do that right? What do you got? Yeah, as n goes to infinity, what does it go to?
250 over 0.260.
250 point what? 0.96.
96.
Yeah. That's a bound. So that's the cap. So what is that? Someone do that for me. What is it?
260.416.
260 point what?
416.
416. So we did 4 pills, and so it meant that that's the hard limit, right? This round right here. What did you guys get? You got 416 right here. Were there probably some other decimals? A little bit. It was probably a little lower than 416, right? Because you're adding to it. It gets there really quickly. Okay, so there are 2 types of geometric series that we're going to look at. There's finite geometric series, and then there are infinite geometric series. The general idea is the A value is going to be your starting amount, and then what's going to happen is the difference between each successive term is going to be some ratio. So in this case, what do you multiply A by to get AX? X. And then how do you get from this to the X? The X. Multiply by X each time. So a finite one ends. How many terms are here? How many terms are right there? There are n of them. There are n of them, right? And then how many are here? An infinite number of them. So the question is, so here we go. So the question is, let's look at the finite one. A plus AX plus AX squared plus ellipses plus AX n minus 2 plus AX n minus 1. If I wanted to, could I multiply everything by n if I wanted to? Sure. How about this? N times S this. What is that going to equal? Oh, sorry, X. I mean X, not N. X. Could I do that if I wanted to?
Sure.
What would that be? AX plus AX cubed plus dot 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 plus AX to the n minus what? N minus 1. That's the exponent, sorry. And then what is it? Plus AX to the n. So we have 2 things. They're both true. Here's the cool thing. Do you notice something that's really similar about these 2 infinite series? Or sorry, finite series?
They cancel each other.
A lot of things cancel. You see this? You see these links right here? If you were to subtract, which is what we're going to do, we're going to subtract, let's say, let's do Sn. Let me go back here. If we did Sn minus X Sn, what do you end up with? What's left?
It's just going to be
A minus what?
AXN.
To the n, exactly. Now what can we factor out on the left and what can we factor out on the right? Sn, yeah, it's hard to say. 1 minus what? X equals A times 1 minus what? To the n, exactly. Nice. So what do you end up with? The sum of n is equal to A1 minus xn all over what? So if you have an initial amount and you know what the ratio between terms is, this will give you the sum of a finite series. The sum of a finite series. Are we always going to look at finite series? No. If we're looking at an infinite series, we will have a starting amount, we will have a ratio, but what is n going to go to? Infinity. If a is some number and x is some ratio and n goes to infinity, is this always going to converge?
Depends.
It depends. So no, it's not always going to converge. It is definitely not always going to converge. My question to you is, when will that converge and when will it not converge?
When it's just 1
Yes.
is 1, x is 1.
Ah, so that's the question that's related to the question I'm asking right now. So the question is this. The limit as n goes to infinity of a 1 minus x to the n over 1 minus x, when does that actually go to something other? When does that converge and when does that diverge?
If x is greater or smaller than 1.
Ah, if x is, so if x, the absolute value of x is less than 1, what happens? Come on in. It converges. It converges. Because it converges to a over what? 1 minus x. Because if x is less than 1, if the absolute value is less than 1 and you raise it to some infinite power, what happens?
It
Goes to 0. But what happens if x is, the absolute value of x is greater than 1? It diverges. And it blows up. I like that. But what happens if x is 1?
You can't do that.
You could. If it's 1, it's just going to be a plus a plus a plus a plus a. Does that converge or diverge? It diverges. It diverges. It's n times a, right? So you can do that. If x is greater than or equal to 1, then it will diverge, because it would be A plus A plus A. How many do you have? N of them.
Yes.
So how big does that get if n goes to infinity? It diverges. It diverges. To the next, what happens? You multiply by a half. So in this case, what is A? What's the first term?
1.
1. What's our x value?
1/2.
1/2. So we know, the formula tells us that this sum, because the absolute value of 1/2 is less than 1, what's the sum of this going to be? And that's not what I wanted. The sum of it's going to be
2.
1 over 1 minus a half, which is going to be 2.
2.
It's 2. The formula we have is right up here. If you have this is true, it converges to a over 1 minus x. So what was our ratio? Our ratio was 1/2, our x, and our initial value was 1. So that's our only tool right now. Okay, so let's work on one that's more. This one right here, it says people who save money often do so by putting some fixed amount into an account. Usually, like every month you put a certain amount aside. To be specific, suppose $1,000 is deposited every year into a savings account, earning 5% a year. So you put money in an account, every year it earns 5%, compounded annually, so once a year. What is the balance B and in dollars in the savings account right after the nth deposit? So let me clarify, and this is a side note I wanted to cover before you left, so I'm going to put it down here. The question is, if you had $1,000 in 1 year, you multiply it by 1.05 and you end up with 1,050, right? What happens if you wanted it to be 1,000? How much money do you start with? You do, principal is going to be 1,000 divided by 105. So that's after 1 year, right? So that just is as clear as I can get on a direct hint for one of the homework questions tonight. This one's a little easier. This one's a little easier because it's not asking you for the present value of the money. It's just asking you for how much money is in the account, right? And how many years does it give you after the nth deposit?
So you put in 1,000 every single year?
Every single year you're putting it in, right? So if you're putting in $1,000 every single year, this was a lot easier than what we just did. But I wanted to make sure you had that information before the bell rang. Well, there's no bell in this school. So, Flipping tool, you see this little thing? This is a built-in program in Windows 7 and 8. When you launch it and hit new, whatever you're looking at on the screen, you can do this. It clips it, you can right-click and go copy, and then paste it wherever you want. That's the easiest way because it works anywhere. Anything you can see, you can clip it in. They're also in, I think one of these, you can change the options so that instead of a square, you can clip with like a boundary that doesn't have, I like a square because I like to paste it in. It doesn't have to be. So that's the first way you can